Hello everyone, welcome to lecture 18. Today we will talk about the remote sensing for river health. So before we start the remote sensing aspect, let us talk about the river health and what exactly we mean by river health, why it is important and why remote sensing is required as a tool to study or investigate river health. So you might have seen a river and its different form, right? So let us understand what exactly we mean by river health, why it is important. So river health is important to maintain the ecological balance. So you might be having some idea about the ecological balance, then sustain biodiversity in that particular river, and it also supports the groundwater recharge, and it is very crucial for water quality regulation and agriculture activities. The cultural livelihoods of riparian communities depends upon the health of the river. If the health is not good, if the water quality or the water discharge that is not within the regime of this particular river, then everything will get imbalanced, right? So why at all this river recovery is important? So the importance of river health, we have discussed this in the previous slide. It helps to maintain the ecological balance, sustain biodiversity and also supports the groundwater recharge. And this is very crucial for water quality regulation, agriculture and the cultural livelihoods of riparian communities, right? And the impacts of anthropogenic activities and the climate induced hydrological changes, these two are the major factor that affects the river health. So when we talk about the impacts of anthropogenic activity, let's say dam construction in a particular river channel, it definitely disrupts the natural flow regime of that particular river, and which alters the sediment transport and fragment habitats, right. Land use change like urbanization, mining, increased runoff, erosion and pollutants loads that also have the direct impact on the river health, right. Then comes the climate induced hydrological changes. So it alters monsoon pattern, increases the frequency of extreme flood and drought conditions, right. Reduced snow or glacier melt changes flow timing in Himalayan rivers like the Brahmaputra. So these two are the major factor which actually affects the river health, and that is why we are talking about the concept of river recovery, whether a river can recover its original state or whether it can stabilize so that the ecological environment will be rebuilt, right. So the key components of river health are hydrological integrity, morphological structure, ecological health and biological indicators. So let us see one by one. So if we talk about hydrological integrity, here we include the flow regime, water quality, sediment transport, base flow stability and hydrological connectivity. So here you can see this is a conceptual diagram. The second one is the morphological structure. It assesses the channel form, so basically the geomorphology, right, bed composition, bank stability, sediment dynamics and floodplain interaction. So here you can see the bed composition, sediment dynamics and floodplain interaction are part of this morphological structure. Then comes the ecological health. It focuses on the biodiversity, ecosystem function, habitat diversity and presence of invasive or indicator species. So that actually helps to establish the ecological ecosystem in a particular river system. Then comes the biological indicator. Here we try to monitor the fishes, microinvertebrates, riparian vegetation, microbial activity and trophic structures, right. So, here these 4 are the different key components of river health. These are the indicators whether a river is towards the degraded form or whether it is recovering its original state or whether it is in the normal state. The geomorphic river condition is related to the physical state of the river, which measures the capacity to perform functions that are expected of the river type and the environmental setting. A solid understanding of direction and rate of channel evolution is also necessary to predict the likely future scenarios of that particular river. River recovery is defined as the trajectory of post disturbance changes towards a degraded or improved condition and assigning the accurate physical state. So, let us say you have a river system here. Because of the external changes or external forces, what happens? It changes from a straight to meandering and meandering to braided. So, that is also a possibility. So, there will be change in the geomorphic river condition, right. Then further what happens, because of these understanding of direction and rate of channel evolution, right. So, then you can predict what will be the scenario after 25 years or 50 years or maybe 10 years, right. So, that will help you to establish the current state of that particular river based on the geomorphological condition. River recovery potential is also related to the connectivity of the reach throughout the catchment and interpreting the limiting factor to recovery. So, this river recovery, whether a river is having the potential to recover to its original state or not, that is we are going to study. In Indian regulated river, so when we talk about the regulated river, that means that particular river has a dam, right. So, we are regulating the water, and because of the dam construction, what will happen? The sediment flow will not be in its original form. So, that will get accumulated in the dams, and the later part in the lower reaches you will have less sediment transport, right. So, here in Indian regulated rivers, this study dealings with river condition and recovery potential are scarce. Vegetation can play a key role in long term landscape adjustment of regulated Himalayan and peninsular river. Thus, framing the role of vegetation in the recovery potential of Indian regulated river requires identifying the vegetated landform and its associated process form interaction. So, here first you need to understand, in India there are very limited studies which are available which talks about the river recovery or river health, right. So, framing the role of vegetation and recovery potential in Indian river is very much required. For the Indian scenario, to establish the river recovery concept, we need to have this process form interaction knowledge, right. So, what is this process form interaction? So, the process, the geomorphological processes and the discharge, the sediment, all these should be known for a particular river, and then only we will be able to talk about the river health or the river recovery. So, let us understand this river recovery in these 4 components. So, geomorphic river condition and performance capacity, where we talk about the physical state of the river, performance capacity expected in future, and then environmental setting. Then we have direction and rate of channel evolution. So, here we talk about the understanding future scenarios and defining river recovery as post disturbance change trajectory. For the Indian regulated river and river condition studies, the studies on river condition and recovery potential are very limited. Then comes the role of vegetation. Identifying vegetated landform and related process form interaction it is very much required to establish the river recovery concept for Indian regulated rivers, right. So, here you can see we have two examples, one is Himalayan river, that we have Brahmaputra, and we have peninsular river. So, here if you compare the geomorphic units of these two different sets, so here you can see this Himalayan river is a very complex river, right. So, here if you see, you have flood plains, secondary channels, primary channels, tertiary channel, and then again you have flood plains. When we talk about this peninsular river, here you have flood plain and then you have low flow channels, right, and you also have a few sandbars. So, steps to recovery assessment: identifying the expected or misplaced geomorphic units, identifying the vegetated landforms and associated process form interaction. Then we need to identify the dominant limiting factors to recovery, implications of channel forming discharge. So, this is a conceptual diagram describing the geomorphic unit and steps for recovery assessment in anthropogenically disturbed Himalayan and peninsular river. So, these two different types of rivers are dominated in India. So, that is why we are having both the components in our river recovery assessment. So, when we talk about this river process form framework, so here you have this form which is equal to the function of P and M. So, P is the process and it can be hydraulic, should have sediment, or it can be vegetation driven, and M is the material. So, whether it is gravel or sand, silt, clay, or it is a mixed one, and the dt is the duration over which the interaction is taking place. So, here you can further understand this concept. So, the P is the external and internal forces such as water flow, sediment transport, or the vegetation, and M is the resistance and properties of boundaries material, sediment, rock and vegetation. F is the physical expression of the river channel over time. So, how it is going to express the relationship between material and the form, right. So, here the same thing has been explained. So, the process encompasses external and internal forces such as water flow, sediment transport, vegetation colonization, and anthropogenic control acting on the system, where M is basically the material. It refers to the resistance and properties of boundaries material, sediments, rock and vegetation that interact with hydrodynamic forces. Then we have F, that is the form. So, the resultant physical expression of the river channel, for example, bar, benches, floodplains, shaped by the temporal integration of processes acting on materials over time. The morphological continuum represents the natural progression and transformation of river channel form from straight to meandering to braided, driven by variation in slope, sediment supply and discharge. So, you all will agree that the straight to meandering, this transformation is driven by the slope, sediment supply and discharge, right. So, it reflects channel dynamics and sediment mobility. Indicators include sinuosity, bar formation, channel splitting and braid plane development. So, here you see this particular example is for straight one. Then here you have transitional phase, it is basically the meandering, and then here you have the braided one, right. It helps to assess the geomorphic condition and recovery stage of rivers. So, this particular slide is meant to explain what is the river recovery stages. So, whether a particular river is moving towards the degraded form, or here when we are having the external forces or the anthropogenic activities, whether it is going towards these two directions. One can be created condition, right, and another is the restored condition. So, this is the recovery phase, and here suppose this is a straight channel. So, here because of this anthropogenic activities, whether it is going to be a meandering channel or braided one, right. So, this will be coming here in the created condition. So, this is the turning point where we have the anthropogenic activities. So, it can go in this direction or it can go in these two directions. So, this is a conceptual framework is used to assess geomorphic river condition. The vertical axis on the left represents the spectrum from an intact to degraded river state. Two distinct recovery pathways emerges on the right. One path leads to the restored condition, this one, and this gradually returns to a state similar to its original form. So, it will both will be almost similar. The other path moves towards a created condition representing irreversible geomorphic change that results in a new altered river state, because once it has changed from straight to meandering or braided, it cannot go back to the straight, right. So, that is what we are saying, that it is irreversible. Here there are some indicators. When we go to the field, we have these parameters. So, we can see the channel platform. So, given the prevailing slope, grain size, valley width, discharge, upstream catchment area, is channel platform appropriate, that we can assess. Then we have channel geometry, then we have geomorphic units, then we have bed bank character and material caliber distribution, then we have vegetation character and coarse woody debris loading. So, all these can be observed in the field when we go for the field investigation. Then we have anomalous processes or accelerated rates of activities, channel floodplain links, hydraulic relationship. So, R roughness characteristic and hydraulic diversity along the reach appropriate for the river style and reach setting. Then sediment regime. Then we have this geomorphic changes. So, is the reach resilient or sensitive to change? What are the type and pattern of change that could occur along the reach? Are there any sign of instability in the reach? All these can be identified